Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. Contest alert. This week we have a jam-packed intro, including a new contest we're launching, so please bear with me. You don't want to miss this one. First, a bit about this week's shows. As you may know, I spent a few days at CES earlier this month. While there, I spoke with a bunch of folks applying AI in the consumer electronics industry, and I'm including you in those conversations via this series of shows. Stay tuned as we explore some of the very cool ways that machine learning and AI are being used to enhance our everyday lives. This includes work being done at Anki, who built Cosmo, the cutest little computer vision-powered robot. Lighthouse, whose smart home security camera combines 3D sensing with deep learning and NLP. Intel, who's using the single-shot multi-box image detection algorithm to personalize video feeds for the Ferrari Challenge North America. Firstbeat, a company whose machine learning algorithms analyze your heartbeat data to provide personalized insights into stress, exercise, and sleep patterns. Reality AI and Koito, who have partnered to bring machine learning-based adaptive driving beams or automatically adjusting high beams to the US. And last but not least, Ariel.ai, who applies sophisticated analytics to Wi-Fi signals to enable some really interesting home automation and healthcare applications. Now, as if 6 amazing interviews wasn't enough, a few of these companies have been so kind as to provide us with products for you, the TWiML community. In keeping with the theme of this series, our contest will be a little different this time. To enter, we want to hear from you about the role AI is playing in your home and personal life and where you see it going. Just head on over to twimlai.com/myAIcontest, fire up your webcam or smartphone camera, and tell us your story in 2 minutes or less. We'll post the videos to YouTube, and the video with the most likes wins their choice of great prizes, including an Anki Cosmo, a Lighthouse smart home camera, and more. Submissions will be taken until February 11th, and voting will remain open until February 18th. Good luck. Before we dive into today's show, I'd like to thank our friends at Intel AI for their continued support of this podcast. Intel was extremely active at this year's CES, with a bunch of AI, autonomous driving, and VR-related announcements. One of the more interesting partnerships they announced was a collaboration with the Ferrari Challenge North America race series. Along with the folks at Ferrari Challenge, Intel AI aspires to make the race viewing experience more personalized by using deep computer vision to detect and monitor individual race cars via camera feeds and allow viewers to choose the specific car's feeds that they'd like to watch. Look for my conversation with Intel's Andy Keller and Emil Chindicki earlier in this series for an in-depth discussion about this project. And be sure to visit ai.intel.com where you'll find Andy's technical blog post on the topic. Now, about today's show. In this episode, I'm joined by Ilkka Korhonen, Vice President of Technology at Firstbeat, a company whose algorithms are embedded in fitness watches from companies like Garmin and Suunto, and which use your heartbeat data to offer personalized insights into stress, fitness, recovery, and sleep patterns. We cover a ton about Firstbeat in the conversation, including how they transform the sensor readings into more actionable data, their use of a digital physiological model of the human body, how they use sensor data to identify and predict physiological changes within the body, and some of the opportunities that Firstbeat has to further apply machine learning in the future. And now, on to the show. All right, everyone. I am on the line with Ilka Korhonen. Ilka is Vice President of Technology at Firstbeat, a company that I first met with at CES. In fact, I met Ilka at CES, and he was kind enough to agree to jump on the line for an interview. Ilka, welcome to This Week in Machine Learning and AI.
Thank you very much.
So why don't we get started by having you tell us a little bit about your background?
Yeah, so my background is that I've been doing biomedical engineering for basically entire my professional career. I did on 90s. I was working on biomedical engineering and ambulatory heart rate variability monitoring, believe it or not, and activity tracking. But the technologies were quite different at that time. So gradually. I moved I did research at that time, but then gradually moving towards wellness and preventative care. While finally later in 2009, I decided to take a career move and went to industry. First for Nokia, and later I span off with some colleagues a company called Pulse which is one of the pioneers in optical heart rate tracking, and later on, about a year ago, I quit that, and now I'm with Firstbeat on doing the next level of the in the stack, so to say, the heart rate analytics rather than measurement. So that's in brief my background.
And for those who aren't familiar with Firstbeat, maybe a little bit more about what that company does. I happen to know a teeny bit about it because Firstbeat's embedded in the fitness watch that I use, the Garmin VivoActive 3.
Yeah, that's correct. So our core business is that we are doing heart rate analytics. So we transform the heart rate reading into something actionable and meaningful for the user. We were established in 2002 as a spin-off of the University of Jyväskylä, and we first looked at heart rate variability as a parameter or method for controlling the athletes' overtraining. But soon we realized that actually, while we try to detect and prevent overtraining with heart rate variability-based methods, those are also applicable for regular people who are struggling with stress and recovery. So that's where we started, and gradually we have been moving into other domains from elite sports. We still do have this elite sports, so we are serving elite teams like NHL, NBA, etc. kind of teams and their coaches for optimizing the training and recovery of their athletes, but more, I think, better known area where we are is that we do develop and license the heart rate analytics algorithms for wearables. So for example, Garmin, Huawei, Suunto, and some other brands, they are using our analytics to transform the sensor reading into more actionable information like fitness level, calorie consumption, stress and recovery metrics, etc.
Now, I've had a couple of conversations on the podcast about IoT and some of the challenges of analytics in an IoT environment. And I guess when I think about this device on my wrist, it's kind of like an IoT in the small, and all of the challenges, well, not all of them, but some of the challenges that are typical for IoT, in particular, the noisiness of the sensor readings and things like that. I get the impression that there's a lot of that going on with regards to kind of the heart rate sensor in the wearables.
That's very correct. So that's absolutely true. So the typical limitations or requirements of the IoT are that the sensor is very power limited and capacity or resource limited environment, in that sense that you don't have the supercomputer power there. You have limited amount of battery. You want to use as efficiently as possible to have the battery lifetime as long as possible. Still, you want to have a rich information from multiple sensors. So, for example, typical Garmin sportswatch has a motion sensor and barometer, in addition to heart rate monitor and GPS, and then of course all these radios. So it's quite interesting. From 80s or 90s perspective, in fact, it would be a supercomputer, but nowadays it's not, and things with what are being done there are quite fascinating. The other thing I think, which is very, very different from, for example, as I told, I started with biomedical engineering on 90s when we were working with hospital systems and monitoring of a patient in a hospital. There were the monitoring was continuous and controlled in a way, but here it's very liberal, or there are a lot of decrease of freedom in the sensor use also, that it's people are wearing the sensor not continuously, but on sometimes they are wearing, sometimes they are not, and also the way how they wear it, how they attach the sensor to their wrist, and how snug it fits to the wrist, and so on. They are not so well controlled, and that causes a lot of variation in the signal quality. Also, ambient parameters like temperature, ambient light, and motion, and so on, they affect a lot the sensor reading. So it's quite challenging data what is measured by these sensors, and there's quite sophisticated algorithms and detection technologies which are required to make sense out of that.
And so for the devices that Firstbeat is embedded in, are you pulling data directly off of the sensors and kind of responsible for giving the watch kind of everything from the ground up, the heart rate itself, plus the higher level metrics that you're providing? Or does the watch or the sensor provide some of those metrics and you're doing higher level analytics on top of that?
It's rather the latter. So our interface to the sensor is typically the heart rate and beat to beat heart rate, and also we use motion and GPS speed and things like that. But we don't do the heart rate detection, but we do the as I said, we transform the heart rate and heart rate variability data into actionable information. So it's a little bit higher level analytics based on a physiological model and of how the human physiology works, and how the autonomic nervous system controls the heart rate and heart rate variability, and how this kind of data can be interpreted in terms of physiology and behavior.
Okay, so before we get into the company's approach to the analytics, maybe take a moment to talk about heart rate variability and how that's calculated and why that number is important.
Yeah, so heart rate variability refers to beat-to-beat variation in the interval between the heartbeats. So each successive heartbeat is having certain time instant in between them, and this time difference between successive heartbeats is varying as a function of time. So and this variation is related to the functioning of the so-called autonomic nervous system, which controls all our autonomic body functions like respiration, perspiration, and blood pressure and heart rate, among others. So this autonomic nervous system is usually divided into two branches, which are a sympathetic and parasympathetic branch. So this sympathetic branch is responsible for so-called fight or flight response. So whenever our physiological resources are needed, the sympathetic nervous system activates and prepares the body for the new requirements, like increased energy expenditure or increased physical activity or increased mental activity, and that is actually what happens when we have a body physical activity, or when we have mental activity or elevated stress, for example. It's the sympathetic nervous system which activates, and that can be seen as an elevated heart rate and in broad terms reduced amount of heart rate variability. The parasympathetic part is the other nervous branch, and that is responsible for cooling down the body after the requirements or immediate requirements of the situation are over. So to basically recover the resources and reduce the heart rate, increase the heart rate variability rate, and so on. And as said, this is in broad terms. The functioning of these autonomic nervous system branches are seen in the heart rate and heart rate variability. It sounds simple, and the principle is quite simple, but the challenge is that, of course, there's huge inter-individual and also intra-individual variance between in this, especially heart rate variability. They are affected by several factors like different substances and in addition to stress and physical or mental requirements, also our metabolism and so on play a role there, and people are different, so their interpretation is quite challenging. In fact, this phenomena was identified years ago, and there's been active research in the heart rate variability since early 70s. But only quite recently, during last 10 years or so, we have learned how to truly manage all these different factors which affect the phenomenon, and how we can transform the information into something which is useful.
And in order to do that, it requires an approach to analytics that takes into account not just the not just kind of the raw data that you're pulling off of these sensors, but also a model of how the body works. Is that right?
Yeah, that's right. So, for example, our approach for the heart rate variability analytics is that we have constructed a digital physiological model of the human body or body functions. So we have figured out the physiological mechanisms, for example, how respiration, physical activity, heart rate, mental activity, how they affect each other, how they are related, and how heart rate variability reflects these activities. And based on this physiological model, we can interpret the data. That's the physiology part, but then we use the data and data driven machine learning basically to tune the data and to be or to be relevant for each individual, and we have in fact a database of 250,000 individuals where we have a wide range of people with different age, both genders, different physical fitness, and different BMI or weight and height, and by using that data measured during daily life in different conditions, we can numerically adapt this model so that it fits for each individual and produces kind of a personalized but yet standardized outputs.
Can you talk a little bit about the physiological model to get us started? How is that expressed? I'm imagining it's a mathematical model of some sort. What's its kind of size, shape, level of complexity? And is this something that ultimately lives in the device that the end user is wearing?
Yeah, if I start from the end of your question, so yes, it relies we have implemented this model into a software library, and it is embedded into these wearable devices. So these today's supercomputers in a way, and how it works is basically that for each time instant, we have first level is that we have active segmentation of the data that we segment the data, and after that we classify calculate certain features of the data and these physiologically motivated features based on the physiological model. Like, for example, we transform the heart rate and heart rate variability data into oxygen consumption or momentary oxygen consumption, VO2. And then we detect, based on the heart rate variability, we detect the respiratory rate, and based on these basically these two parameters describe the level of physical activity, and also respiratory rate is related to also the physical activity. And based on that, we can classify whether a certain time instant is physical activity or mental activity. And after that, we can also, by looking at the heart rate variability and whether there is sympathetic or parasympathetic dominance, we can classify each time instant whether that is more of mental stress or physiological recovery. And accumulating from that, we can calculate different kind of things, like level of stress during the day and amount of recovery. From the VO2 levels, we also can calculate energy expenditure, etc. And when we combine issues like speed or physical effort, which is measured by the motion sensor, we can also calculate body and using the information like personal heart rate maximum and age and gender and so on, we can estimate the VO2 max, which is the fitness level of the individuals and things like that. So there's actually, we have certain white papers describing that, but there is actually a multitude of different physiological mechanisms embedded. I think it doesn't make sense to go to details, but just to take as an example is that we have modeled that when you start a physical activity, there is certain the heart rate increase is not immediate but gradual, and it also depends on your previous physiological state. Mm-hmm. That, for example, in interval training, we know that the previous interval affects to the next one, and we can have this kind of on-off kind of mechanisms in the model, and those are taken into account. So it's kind of a state compartment model, heavily based on the physiology which is behind there.
And so you mentioned that there's the physiological model and then more of a data-driven model. All of the metrics that you just mentioned, are those all coming out of the physiological model before you even get to the data-driven piece?
How it works is it's basically that we have the principles are physiological, but the parameters or how it really works, how the input data is processed and how the classification and quantification of the different physiological parameters goes. That's heavily data driven. So we have used the big amount of data what we have to tune the parameters of the model and to tune it also or to adapt it to each individual, so that let's say that it data driven personalization of the model, which is done there. I don't know if that makes sense, but
well, in what way is it? How personalized? Like, is this machine learning type of a model that is running, on the device itself, or is it, you're doing analytics using some type of machine learning that spits out some number of different models, and you can choose between models on the watch? How personalized are you able to go with it?
We are using both approaches. So when you take a new device into use, you are asked to provide your background parameters like gender, weight, age, height, and activity level, and those are used to put you broadly to the scale that what is typical for an individual of your age and gender and fitness level. Mm-hmm. But then and that is kind of machine learning or database driven learning with what we continuously update based on the data what we accumulate from our users. But then it's also adaptive model in the sense that we use we have algorithms which adapt the computation to your daily physiological or your normal physiological and physical activity levels and heart rate variability levels and so on. So basically, the devices get more accurate after a couple of days of use when they have the algorithms have learned what is your typical level of heart rate variability and what is your typical responses and your real true heart rate minimums and maximums during different daily activities. So the model adapts to the user, and that is why also these devices are typically designed for personal use. If you would use, for example, share these wearable devices with some of your colleagues or your wife, that would be suboptimal in the same sense that the learning would not converge.
The learning that we're talking about here, it's I don't know what's the right way to ask this question. We're not talking about like training in the sense of training a machine learning model. That's certainly not happening on the wearable device. It's more like tracking the individual's data and adapting the model to the data over time.
Yeah, that is probably more accurate description of that. Yes. So there is in the physiological model, and which is being broadly optimized for your age and gender and weight and etc. So that is being more fine tuned to the your exact characteristics based on the adaptation there. But it is correct. It's more like adaptation.
Mm-hmm. And you mentioned classifying a few times. Are you ending up having to do things like outlier detection and things like that, where you're getting rid of noisy data from the sensor itself? Or does that happen at a lower level?
We hope that most of that happens in a lower level, but in fact, we have a lot of that happening in the analytics layer as well. So especially with optical sensors, there is a lot of noise, a lot of poor data, and in fact, we have built quite a lot of intelligence into the separation or detection of poor and good, appropriate quality data. And what we actually do in the model is that when we detect that the input data is not valid, we have several mechanisms to bridge those gaps or survive without providing false outputs. In fact, to an extent that, for example, our stress and recovery analysis is still providing quite valid outputs up to the error level of 50%, which is quite high. So as long as more data which is coming in is reflecting the real heart rate, then we can provide reasonable analytics. Of course, when there is more false data than real data, then there's little one can do. But
right. And so we've talked primarily about the things that are happening on the device itself, but you've also got this warehouse, so to speak, of data from individuals. What are you, in addition to kind of the work you're doing to develop the models for the device, are there other things that the company is doing to, with machine learning and analytics to take advantage of that data?
Yeah. So we have two other businesses, and one is we provide corporate wellness service called a lifestyle assessment, and there the idea is that we basically sell for corporates who are interested to improve or promote their employer well-being, an assessment service where employees get a heart rate monitor, a special heart rate monitor for 3 days. It's based on ECG, so it's very accurate to 1 millisecond time resolution. And they do 3-day heart rate variability recording together with the diary. And by using those heart rate data and the diary data, we construct a report and give feedback to individuals about their physical activity, sleep, stress, and recovery, and fitness level and things like that. And that those are also compared to the recommendations like physical activity recommendations, sleep recommendations, and what is normal at their age and gender. And that is used very often in this kind of wellness campaigns where people are motivated to improve their lifestyles and improve their stress management skills. So it can be used as an initial measure to assess the starting point and identify the exact activities they should do to improve their lifestyles. And that is something as we sell as a service, and that is actually one source where we get a lot of data. We did last year about 50,000 such assessments.
Oh, wow.
Mostly in Europe, in Finland, UK, Germany, Sweden, now in Singapore as well. Not so much in US yet. But that is actually a good source for data for us. So because we get this kind of last year we got like 150,000 new data sets with documentation and background information and diary, and that is actually what we use for the optimization and further development of our technologies, which we use then for consumer devices. So that is an interesting area, but that's not to say that is just this service is actually used and developed on its own. It's not just for data collection, but it's really just to for corporate wellness business, and we see that actually there's a lot of interest there. About 95% of the people who make the assessment find it very, very useful and recommend it for the others. So it's we're looking at how to scale it up and how to make it more broadly available at the moment.
Mm-hmm. How does a company organize to tackle analytics types of problems or challenges, given the strong domain expertise required, but also the analytical requirements for machine learning and traditional analytics?
Yeah. So we have here in Finland, we have a team of data analysis experts, and then we have a team of physiologists. And in fact, we have organized it so that these two teams are working as a single bigger team. So they work on a daily basis with each other. So they are people who are from data science, and they are sports physiologists and physiologists who are expert in the physiology, and that's the big thing what we are doing that they are basically never doing a single project that only one side of that expertise would be present. Then of course we have engineers with software background and so on to transform all of that into something which can be delivered to customers or implemented into our services. But the core thing there is that the majority of that R&D or intellectual work is done by the data scientists or physiologists.
I guess I'm curious about the opportunities that are created as we continue to advance in our knowledge of applying machine learning and, even some of the newer techniques like deep learning that, might not necessarily be applicable to running on a watch. But do you have any perspectives on what opportunities these technologies and the increased focus on these technologies creates for Firstbeat?
Yeah, certainly. I think we are just getting there. Even though we have data from roughly 250,000 individuals in our databases and so on, it's still it only today I think it starts to be in the scale where I would really truly call it as a big data. So although I do recognize that it's probably quite unique resource that very few organizations would have, or if anybody would have that amount of heart rate variability and background data available. So we are actually applying at the moment. We're looking at things like how we could apply more machine learning type of things, and we have done some experimentation. But I have to say that to date our perspective is very much that there are challenges with applying just pure machine learning without having some kind of a domain knowledge to constrain this kind of a machine learning methods. There is a risk that you over optimize to certain data sets and they don't generalize. And I think one of the learnings what we have done and why our methods also work in the wearable environment and why they work in almost all the individuals is that they are based on this kind of a physiological principles, and we use only data to kind of optimize those principles and make them numerically work. And in that sense, we are not very heavily using for our heart rate data. We are not using this kind of pure machine learning like deep learning kind of methods. We have and we are experimenting on that, but I'm actually not a great believer that would be the optimal way to go.
Great. Well, Ilka, this was a really fascinating conversation, and I appreciate the way that you're combining the physiological models with the data-driven models. And I think clearly the domain knowledge is important here, as is the case in many, if not all of the use cases that folks are having success with. So thanks for taking the time out.
Thank you very much. It was very good for me as well.
All right, everyone, that's our show for today. Thanks so much for listening and for your continued feedback and support. Remember, for your chance to win in our AI at Home giveaway, head on over to TWiMLAI.com/myai contest for complete details. For more information on Ilka, Firstbeat, or any of the topics covered in this episode, head on over to TWiMLAI.com/talk/106. Thanks once again to Intel AI for their sponsorship of this series. To learn more about their partnership with Ferrari North America Challenge and the other things they've been up to, visit ai.intel.com. Of course, we'd be delighted to hear from you, either via a comment on the show notes page or via Twitter, directly to me at Sam Charrington or to the show at TWiMLAI. Thanks once again for listening, and catch you next time.